Replication between vCenter and VMware Cloud Director is a key architecture component for cloud service providers operating in multi-tenant environments and offering disaster recovery as a service. It enables tenants to replicate their virtual servers to the dedicated cloud service provider resources under VMware Cloud Director. In this demonstration, I will present a live failover operation using HPE Zerto between a VMware vCenter and VMware Cloud Director site. This architecture illustrates a hybrid disaster recovery as a service topology. The tenant workload originates in a vCenter managed environment, Site A, and is protected in a VMware Cloud Director managed environment, Site B. It's a common cloud service provider deployment model using VMware Cloud Director for multi-tenancy capabilities. The source environment is a vSphere infrastructure managed via vCenter. In this example, the VM being protected runs inside a resource pool, which enforces tenant-level resource governance. On the recovery side, Zerto creates and maintains journal and replica disks. When a failover is performed, a VAP will be created to host the recovered virtual machine. On the cloud service provider side, the VMware Cloud Director resources integrate with Zerto organizations to enforce tenant boundaries. Each tenant's resources and recovery operations are scoped to their own organization, preventing cross-tenant data exposure. It's essential for compliance and security. We have created Organization 2, and the VMware Cloud Director resources, the virtual data centers, are associated with it. In this case, we are associating Virtual Data Center 2 as the recovery environment for Zerto. Here, we can see a resource pool configured on the tenant side. We have one virtual server that is configured and powered on. We can also see that no VAPs are configured on the cloud service provider. We already have a virtual protection group configured and replicated to the recovery site with an RPO of approximately 2 seconds. Let's edit it to understand its properties. In the general step, specify the name and the priority of the virtual protection group. In VPG type, we chose Remote DR and Continuous Backup. The Ubuntu virtual server to be protected is already selected on the right. It's necessary to define the replication parameters. Select the recovery site and the organization number 2. You can keep the default parameters for journal. In the VM settings, you can change the VM storage profile and specify the hard limit size for the journals and scratch disks. For each virtual machine in the virtual protection group, Zerto displays its storage-related information. You can change it if necessary. You can define the vCD recovery settings and the vApp networking map. In this example, we use the direct network as the failover network. It is also used for failover or move operations. The isolated network is used during a failover test. It's a non-disruptive, fully reversible verification with no impact or interruption on the production VM. You can also change the network interface properties for each VM, for example, to recover the VM with a different MAC or IP address. These are the basic configurations for this virtual protection group. The replication is already established between the tenant and the MSP site. Let's cancel the addition. Now let's start a live failover. We select the VPG and click on Next. You can edit the checkpoint and select any timestamp you need. It's also possible to select checkpoints using tags to identify specific events. You can define a commit policy. In this case, auto commit after 60 minutes. It's also possible to shut down the tenant or production virtual service after the commit action. Reverse protection is the process of automatically flipping the replication direction after a failover live is committed. The VMs now running at the former recovery site are immediately protected back toward the original site. You can edit the reverse protection parameters, for example, by modifying the VM storage profile and storage policy as needed. You can also change the IP addresses and DNS configuration if necessary. This flexibility in the reverse protection procedure is a major advantage of the solution. After the reverse protection edition, click Next and start the failover operation. The failover before commit operation will start. It is a temporary paused state where the recovered VMs are already running at the recovery site, but the operation hasn't been finalized yet. It gives you a window to validate that everything is working before deciding to commit or roll back. The VAP is powered on in the recovered site. The VM is also powered on. You can access the Ubuntu VM at the recovery site and verify that it is in the desired operational state before committing. Let's access the CLI of the recovered virtual server and log in before committing to verify whether it's operational. Reverse protection is enabled, and let's start the commit process. Under the hood, Zerto will perform a promotion process. The scratched journal and replica disks are consolidated into production disks and attached to the VM. During this consolidation process, the recovered virtual machine remains operational and available for use. It reduces the recovery time objective. Here we have a representation of the architecture after the commit and promotion processes. The VAP is powered on at the recovery site, and the virtual server is available for use. At the former production site, journal and replica disks have been created for reverse protection. Zerto reuses the former production VMDK files from the original site as preceded replica disks, rather than copying all information from the promoted disk in Site B. The solution reads the former production VM disks at the original site by data store path as a precede baseline without detaching them from the powered off VMS. It synchronizes only the changed blocks between the replica disk and the promoted disks, dramatically reducing synchronization time and bandwidth usage. Zerto powers off the original protected VM to avoid a split brain condition where both sites could run the same application stack simultaneously. If desired, the resource pool and the virtual server inside A can be deleted without impacting the replica and journal disks or the replication process. Meanwhile, the reverse replication is in sync state. After the synchronization, the VPG protection direction is reversed. The solution also allows you to generate a report containing all the information about the failover procedure. For example, this failover process had a recovery time objective of 1 minute and 59 seconds. It also provides information about the configuration of the virtual protection group used in the procedure. In addition, the report outlines the steps taken during the process and the time spent on each. This is a very useful report for compliance and adherence to cybersecurity regulations. I hope this demonstration was helpful and informative regarding the failover process between a VMware vCenter and a VMware Cloud Director solution environment using the Zerto solution.